Hello everyone, welcome back to my channel Blue Jacket with another video. This is a part 5 session for marine refrigeration system. In this session, you will be learning on refrigeration condenser, high pressure cutout in marine refrigeration system, and a refrigeration filter dryer. But before proceeding further, let us quickly recap into the actual marine refrigeration system used on board ship and the flow of refrigerant in that system. In the earlier sessions, I have shown you this picture, the actual marine refrigeration system used on board ship. Here is the compressor, condenser, thermostatic expansion valve, evaporator. These are the four basic components, and the flow of refrigeration is from discharge side of compressor to condenser, condenser to receiver, receiver to dryer, dryer to siphon glass or a side glass, and side glass to thermostatic switch, then to thermostatic expansion valve, and at last evaporator, and again recycle to the compressor suction side. Now let us understand the marine refrigeration condenser and marine refrigeration filter dryer and siphon glass or side glass. Earlier, I have spoken of from the discharge side of a compressor, the refrigerant is in the gaseous state above the saturation temperature and the saturation pressure. This raised saturation temperature and the saturation pressure of a refrigerant which is in gaseous state is sent to the condenser, and the condenser is provided with the seawater inlet and a seawater outlet. If it is a seawater cooling system, and if the ship is provided with the central cooling system, in the place of seawater, you will be seeing the freshwater inlet and outlet. Here, in the condenser, the gaseous refrigerant that issued from the compressor is cooled down to the saturation temperature. During the cooling down process, the compressed refrigerant from the compressor is undergoing a phase change from gaseous to liquid state. That means at the entry of the condenser, you can see the gaseous refrigerant, and at the exit of the condenser, the refrigerant will be in the liquid state. And this liquid stated condenser refrigerant is sent to the dryer, where in the dryer the contaminant particles are filtered out, and the filtered refrigerant is flown to the side glass and again to the evaporator. Now let us look into the components of condenser, marine refrigeration dryer, and siphon glass or side glass. And this is a marine refrigeration condenser. This is basically a heat exchanger which is of shell and tube type. Here you can see this is the outer shell of the heat exchanger, and this is the tubes where the cooling media flown inside these tubes and the refrigerant is flown inside this shell. And now, what is the purpose of condenser in refrigeration system? I have previously mentioned that the compressed refrigerant from the compressor that is sent to the condenser for a phase change from gaseous state to liquid state, and this is done by seawater by taking away the heat from the compressed refrigerant by the process called convection. Here you can see the purpose is to cool the raised temperature of a marine refrigerant received from the compressor to make a phase change from gaseous state to liquid state. Here, back into this diagram, you can see that this is a shell and tube heat exchanger. Here you can see the inlet of the refrigerant gas which is received from the compressor, and here you can see the outlet of the refrigerant in the liquid phase. Here is the refrigerant issued from the compressor that is cooled with the help of the either seawater, if the ship is provided with the seawater cooling system, or either freshwater if the ship is provided with a central cooling system. Here you can see the inlet of the seawater and outlet of the seawater. The seawater is given at the inlet and is flown inside the tubes. When the seawater is flown inside the tubes, in parallel, the refrigerant issued from the compressor will be in contact with these tubes. When the hot refrigerant that is in contact with these seawater cooling tubes, the heat is taken by the seawater. I have previously mentioned the heat transfer is always from the higher temperature body to lower temperature body. Here, the refrigerant is at higher temperature and the cooling media, which is seawater, is at lower temperature. So, the heat transfer will be from refrigerant to seawater. Here you can see the flow of seawater is always from the bottom, and outlet of seawater is always from the top. This is to ensure proper cooling and maximum efficiency of cooling is done by the heat exchanger, which is a condenser, to take away the maximum heat and also ensure at the outlet of the condenser the refrigerant is to be in liquid form. Now, what is a condenser in refrigeration system? In marine refrigeration system, shell and tube type condenser used for cooling the refrigerant and cooling media flows inside the tubes and the refrigerant flown inside the shell. I have previously mentioned that the refrigerant that is received from the compressor that is flown inside the shell and the seawater is given at the bottom of the condenser and the seawater outlet will be at the top. And now, how the refrigerant is cooled inside the condenser. Back into this picture, you can see the flow of refrigerant and the flow of seawater. Now, for the question, how the refrigerant is cooled inside the condenser. When the refrigerant received from the compressor is entering into the condenser, this is initially cooled to saturation point. In my previous sessions, I have shown you the vapor compression refrigeration cycle. In this diagram or in this graph, you can observe that the entire refrigeration system can be divided into two parts. One, this region is a gaseous region and this region is a liquid line region, and this is the maximum point where the gaseous temperature and pressure can be increased, and this is the maximum point and this point is known as the saturation temperature. And previously I have mentioned that the saturation temperature, it is a temperature at which the medium that undergoes a phase change either from liquid to vapor or a vapor to liquid. Here in this graph, you can observe that the process 1 to 2 compression is doing work for compressing the gaseous refrigerant received from the evaporator. After compressing the gaseous refrigerant, it is increasing the saturation temperature and the saturation pressure. Now, raised saturation temperature must be cooled down in the condenser. So now, the condenser work is to cool the raised saturation temperature of a gaseous refrigerant and change its phase from vapor to liquid. And this is where the process starts by the condenser. That means initially the gaseous refrigerant that is cooled up to the maximum saturation temperature point. Then after that it is changed its phase from gaseous to liquid. Here in this picture you can see the gaseous refrigerant that is received from the compressor is entering in the shell and the seawater is entering in the shell inside the tubes. That somewhere here the refrigerant that is in the gaseous form, and as the seawater entering in the tubes taking away the heat from the gaseous refrigerant, the seawater slowly turns its phase from gaseous to liquid. Somewhere here in the middle in the condenser, the refrigerant can be exist in a mixture of gaseous refrigerant and the liquid refrigerant, and by the time of outlet, the gaseous refrigerant completely converted its phase from gaseous to liquid. This is how the cooling process is done in the marine refrigeration condenser.